Hey folks, do you know what the word data or for that matter variable, what do these two words mean when we talk about statistics? We may have a general idea about what data means, and regarding variables, we might have studied in our maths class, specifically algebra. But when it comes to statistics, these two words have a slightly different meaning. Well, we are going to discuss that in this video. Hi, I am Chaitanya Gunti. I am a data analytics coach and the co-founder of Swachh Data Analytics Hub. I am on a mission to help 1 million working professionals achieve career growth by learning the skills of data analytics. So let's understand what data means and what is the meaning of variable, and also how many different types of variables are there when we talk about statistics. Let's understand that whenever we want to study or analyze certain individuals or certain category of items. For example, items in a grocery store, or maybe it is the students in a class, or maybe it is working professionals in an organization, say an MNC. Maybe it is housewives in a particular locality in a city. Maybe it is retired people. Maybe it is items or specifically automobiles that are being launched in 2023. So whether it is items or whether it is individuals, that is people, we are interested in certain characteristics of the item or individuals. Let's say when it comes to items, we might be interested in the weight, the color, the size, that is dimension. When it comes to individuals, maybe the age, maybe marks obtained by students, maybe the IQ of students, maybe personal interest, maybe height. So these characteristics that we are interested in, they are called as variables in statistics. And if I talk about a variable, say age of a student, the various values that this variable can take, say under 10 years, 10 to 15 years, or maybe 15 and above. These values are what we call data. And when these values convey some useful meaning about that particular item or individual, then we call that information. So this is about the basic meaning of data and variables and how they are associated. Now coming on to variables, there are various kinds of variables when we are dealing with statistics. For example, if we are analyzing students in a class, we might say that we are analyzing boys or girls. We might also say that we are analyzing students whose mother tongue is Hindi, or whose mother tongue is Telugu, or whose mother tongue is Punjabi or Bengali. So what we are talking about here is a variable which cannot be measured per se and which cannot be ranked. I cannot, for example, say that boys are better than girls or girls are better than boys. Or maybe a person whose native is Punjabi has some higher or lower ranking than a person of another native language. These are simply different categories. When it comes to items, let's say we are categorizing items as SUVs, multi-utility vehicles, MUVs, hatchback cars, maybe red color car, blue color car, silver gray. So all these variables, that is color, that is type of vehicle, they're all different what we can say characteristics which cannot be ranked. So these variables are called as qualitative variables, and in statistical language we call them as categorical variables. Now there are other types of variables. For example, when we are again analyzing automobiles, maybe weight of the car, price of the car. These variables have a certain value attached to it. And when we talk about, say, price of a car, we know that we can compare the price of one car with that of another in terms of ranking. And when it comes to individuals, let's say we are talking about marks scored by students. We can rank that score. So these kinds of variables are called quantitative variables. And in statistical language, we call them as numerical variables. So that means categorical variables and numerical variables. Now, this definition in some cases may not be exact or may not be definite. What do we mean by that is, let's take the case of age of participants. So the age of participants can have different values which can be ranked, and then it becomes a numerical variable. Whereas if we are interested in age of participants in terms of participants below 20 years, participants above 40 years, participants above 60 years, then we suddenly are transforming the notion of this parameter or property by taking it out of the ranking system. So when we say below 20, above 40, above 60, we are just understanding that these are different sets of individuals. We cannot rank them without any other property or measurement involved. So now age can be considered as a categorical variable, as in this case, or numerical variable, as in the case when we are simply tabulating age of participants in terms of 15 years, 16 years, 17 years, and so on. So depending on the context, age has become either a categorical variable or a numerical variable. So there are certain cases where a variable can be considered as categorical or numerical depending on the context. And there are cases where variables fall strictly under the definition of either categorical, for example, color, or numerical, for example, marks. Now, having understood these two primary categories, let's further go on to understand that numerical variables can fall under two types. One, wherein the variables can take continuous values. For example, dimensions of a house. So the length, breadth, and height. It can be a continuous variable. 50 meters can be the length of a playground. 50.5 meters can also be the length of the playground. So it's a continuous variable. The values are continuous, real number values. Now, there are certain variables, that is numerical variables, that cannot be considered as continuous. For example, if I talk about number of students in a class, I can say 1 student, 2 students, 0 students, 3 students. I cannot say 3.2 students. So these values are now taking integer values. So when it comes to numerical variables, we can have continuous variables, and these continuous variables arise from measurement. Maybe I'm measuring the dimensions of a playground or that of a house. Maybe I'm measuring the height of a person. The other variables, which are discrete variables, having discrete values, they are arrived from a counting process. I'm counting the number of participants, number of students, number of voters, number of items. So the numerical variables can be continuous variables, which arise from a measurement process, or discrete variables, which arise from counting process. Now, further on, we talk about scales of measurement. So in this context, we have the numerical variables as either interval scale or ratio scale. But before we discuss these, let's understand that even categorical variables are subdivided into two scales. One is the nominal scale and one is the ordinal scale. Now, what is nominal scale and what is ordinal scale? Nominal scale. let's say I'm analyzing the data of cars based on their color. A blue car, black car, white car, maroon car, and so on. These are different color cars. And for a second, let's assume that it's only the color which is the differentiator in the cars. There is no other differentiator in terms of price or features or other things. It's just the color of the car which we are talking about, which is different for different cars. So now what we are talking about is the nominal value. I cannot rank a blue car better or worse than a white car. It's in my mind. Maybe one person feels that a black car is better than a white car in terms of its look, but it's a qualitative parameter. In general, we cannot rank these type of variables as one being higher than the other. So this category is called nominal variables. And these variables really don't give us much information. They simply tell us that these are different categories we are looking into. There is the next category of categorical variables that is slightly better because it can help us in ranking these various items or individuals. For example, let us say we've gone to a hotel, maybe booked on Make My Trip. So after we complete the trip, we receive an email from Make My Trip to rate the experience we have had in that hotel on a scale of say 1 to 5, or let's say they term 1 as not satisfied and 5 as extremely satisfied. So not satisfied, somewhat satisfied, fair enough, very much satisfied, and totally extremely satisfied, or become a fan. These are 5 different uh, levels or values, and we know that not satisfied is having a lower ranking than extremely satisfied. So this is the second category of scales in which we can consider the categorical variables. First was the nominal, where we could not compare. Now we are able to compare, but still we don't know what is the gap between not satisfied and somewhat satisfied. We know that there are two different levels. Maybe somewhat satisfied is a higher level than the not satisfied, but exactly how much difference we are not sure of. So the ordinal values suffer from this limitation, that though they help us in the ranking, they are not able to help us measure the extent of gap between two individual levels in the ranking. Now coming on to the numerical variables, which we already said that they can be measured on a scale of say interval scale or ratio scale. Now interval scale is slightly better than this nominal, sorry, slightly better than the ordinal. So first we had nominal where we could not rank, then we came to ordinal where we were able to rank them from extremely unsatisfactory to extremely satisfactory. Now we are coming to interval scale. Interval scale helps us in identifying the gap between two levels. For example, let's talk about temperature of two cities. Say Bangalore, it is 20 degrees Celsius on a particular day, and Mumbai 27 degrees Celsius on the same day. So now we know the gap between 20 degrees Celsius and 27 degrees Celsius. And this is the same gap which exists between 27 degrees Celsius and a place where it is 34 degrees Celsius. So the gap is 7 degrees Celsius. So the temperature measurement is an interval scale. It is better than the ordinal scale because now we not only know which one is better, but how much better. However, in the interval scale, we have defined 0 degrees Celsius and 100 degrees Celsius as some lowest point and highest point of measurement. But the 0 degrees Celsius is not what we talk about universal zero, or we cannot, because it is a relative parameter. 0 degrees Celsius is based on a certain observation we have, let's say melting point of ice. It's not something which is zero on a universal level. in a Fahrenheit scale, it is 32 degrees Fahrenheit where we consider the melting point of ice. So now two different values. That means there is no universally same value in this kind of system also. So the interval scale tells us what is the gap that is existing between two different levels, but it cannot be compared to a universally zero level. So proceeding next to the ratio scale, let's take an example. For example, if I am talking about weight of a particular item that I am intending to purchase in a grocery store. Let's say I am purchasing 5 kilos of rice. So now what's happening is I know that 0 kilo of rice is universally zero for everyone, unlike the 0 degrees Celsius. So when I talk of 0 kilo, everybody understands I'm not taking any quantity. And when I'm taking 5 kg, I know not only that 5 kg is higher than 0 kg, I exactly know what is the gap between 0 and 5 kg. And it is the same as between the 5 and 10 kg. So it is having the property of interval scale plus an additional property of having a universally constant zero level. This is the ratio scale. And this is the highest level of a variable for statistical analysis purpose because it gives us the maximum amount of information. It gives us the information about the different levels, which is higher and lower. It also gives us the gap between two different levels, how much, and it also tells us how I can compare the gap with a relative zero, which is actually universally same for every item under that consideration. So let's recapitulate what we've discussed. We have discussed data and variables. So variables are the properties or the traits or the characteristic of items or individuals under consideration, and what values these characteristics take that comprise the data. And when it comes to variables, we have two types: qualitative, that is categorical; quantitative, that is numerical. In numerical, again, discrete, which is a result of counting process; continuous, which is the result of measurement process. We further discussed that there are different scales of measurement. Categorical can be subdivided into nominal scale, where we cannot rank; ordinal scale, where we can rank, but the gap we don't know; numerical variables; interval scale, where we know the gap, we know how much is the gap, but we cannot compare this gap with a universal zero; and then ratio scale, where we also have the zero level. So let's understand this in terms of slides for those of you who find it better to learn from visuals. So here we go. So there you go. Hope you like this video. If you have any thoughts or doubts regarding any topic discussed in this video, feel free to share in the comments below. Happy learning once again. Bye.